This phenomenon, known as the fast radio burst, first appeared about 20 years ago. At first, researchers thought it was a natural phenomenon, but as the signals accumulated, the situation presented an intractable puzzle to science. Could the last herd of extremely fast and frequent flashes have come from a single object, or even from an alien civilization in space? Find out what science knows about the phenomenon so far and the likelihood that this is first contact with an alien civilization. In this video, NASA and many scientists around the world are listening into space with giant radio telescopes, which allow for unique impressions of corners of space and of events that are not visible but audible during these listening investigations. Prior to delving into the topic itself, we would like to ask you for your input on the channel. Your thoughts and opinions are valued, so please share them with us. If you enjoy the video, it will receive a heart from our subscribers, and your significant contribution will be pinned at the top so that everyone sees it first. Just make sure you have already subscribed, like the video, and mention both at the top of your comment. Next up is the phenomenon known as fast radio bursts, or FRBs for short, music. A concerning finding. As part of an investigation of pulsars, which are neutron stars, the remains of exploding suns, the first fast radio burst was found in 2001. Pulsars rotate very quickly and generate a lot of radiation. Researchers in Australia painstakingly went through data from the Parkes radio telescope and discovered not only signals clearly emanating from pulsars, but also a whole new category of radio frequencies that, while similar in some ways to pulsar, signals are quite different. Pulsars emit periodically repeating signals due to their extremely fast rotation, while the new discovery emits only one pulse at a time, with the duration of this pulse being slightly longer than the signal of a pulsar with frequencies just over 1 millisecond. In specialist circles, the phenomena is also known as blitzar, but it was originally observed in 2001. In 2006, the presence of these entirely new and enigmatic signals was confirmed with certainty. The new discovery was titled fast radio burst. Interestingly, the pulse profile of these fast radio bursts resembles the symmetrical shape of an isosceles triangle in the graphical representation. In theory, researchers were first only able to identify an object or event as the source that emits extremely strong radiation that can produce signals like these. These are always neutron stars that are formed after a star explodes supernovally. Depending on their radiation intensity, these neutron stars are classified as either magnetars or pulsars, but they immediately began looking for potential sources. Until today, it was not possible to use optical telescopes to trace the origin of flashers or FRBs. This means that not only were the flashers or FRBs not traceable to clear sources, but space events that emit light and are therefore visible with optical telescopes cannot yet be matched with the auditory impressions of the lightning stars. Another fact that researchers soon had to deal with was that the number of FRBs in the universe is rapidly growing. By 2017, researchers worldwide had discovered 25 FRBs, and today there are approximately 800. The observations and frequencies kept repeating themselves. In the process, they exhibit typical scattering, which means that individual frequencies reach Earth faster than others. Another way to describe this is that the signals arrive at our telescopes piecemeal or stretched. It is precisely this signal stretching that enables the researchers to make further inferences about the direction of movement of the lightning stars, which should also enable them to determine the source. However, no matter how hard the researchers tried to trace the lightning stars back to their origins, they were unable to do so. Instead, the signals remained like ghostly calls in the cosmos. Resistances on their path through space caused the extremely fast radio flashes to scatter or disperse. Similarly, light and other auditory signals travel in waves through plasma over great distances. Space experiments have demonstrated that the signals are slowed down by free electrons in the plasma. Compared to high frequencies, low frequencies with high wavelengths are more impacted. Although gamma-ray bursts or gearbs that originate near our solar system and are directed towards Earth could cause a global catastrophe or even lead to mass extinction, gamma-ray bursts have only been observed at very long distances from Earth or even in other galaxies. This situation was similar to that of fast radio flashes before 2020, when they were only observed outside the Milky Way. Scientists believe that lightning of certain types of radiation can extend over long distances in the cosmos and can also cause damage depending on the type of radiation. Researchers were able to more accurately deduce a potential source inside the Milky Way. Some astronomers were positive they had located magnetars as the main cause of these high-energy explosions. For the first time, this explanation initially made sense. Magnetars are pulsars that emit extremely strong radiation. However, as more questions and puzzles emerged regarding the fast radio signals, their frequency abruptly increased to the point where some researchers came to the conclusion that the source of the FRBs, or lightning stars, was probably not natural. What would this mean in practice, though? Is it really possible that lightning stars are indicators of broadcast frequencies from extraterrestrial civilizations? Recent measurements by a Chinese telescope of many FRBs, all pointing in the same direction, would naturally imply that the source is a massive magnetar. However, the FRBs reveal anomalies that essentially rule out a natural source and all known neutron stars, magnetars, or pulsars as a source. The signals are distinct, fluctuate in frequency, and do not repeat during specific times. In 2007, Dr. Duncan Lorimer was one of the few researchers to identify a pulsar in the Magellanic Cloud as the source of a received FRB. However, this signal appeared once and then never again. To date, only 19 of the more than 800 FRBs identified could be clearly attributed to natural sources. This is because a pulsar or magnetar rotates at a certain speed, which could produce signals. However, both the speed and the emission of the radiation are subject to cyclic repetition rates. Because of this, several scientists ventured to propose the audacious theory that the brightest bursts to date displayed a scatter broadening with power law dependencies, suggesting radio emissions from extraterrestrial origins. Other scientists quickly rejected these theories and asserted that FRBs were caused by infrequent cosmic occurrences like white star explosions or neutron star mergers. What will 2022's FRB 121-102 reveal? It was shocking to learn that a Chinese fast telescope had captured FRBs from a single source for 47 days. Since its discovery, the phenomena, known as FRB 121-102, has sparked significant debate. Instead of transmitting a single signal that was heard for a brief moment before dying away, FM 121-102 radioed roughly 1,000 distinct signals over the course of less than 2 months of observation. During the most active hour, the signal flared, up more than 120 times, but it was always only heard for a fraction of a second. The repetitions lacked periodic correlations that would indicate a natural phenomenon, so during the observation period, the signal was active once for 90 days, and then there was a 67-day period of complete radio silence. Since scientists from all over the world have been closely examining the phenomenon of fast radio flashes, researchers are unable to say with certainty whether all of these signals are actually part of the same phenomenon at this time. However, the chaotic and frequent sounding of these flashes allowed for the confirmation of an extraterrestrial radio source once more. A dwarf galaxy in the constellation of Fermi, approximately 3 billion light-years away, could be identified with certainty, as the point of origin FRBs with different origin. Researchers have identified a number of categories, including flashes that emit a single sound before ceasing to exist, flashes like those that occur on frequency 121-102 that emit a frenzied series of signals, and lightning stars that can be classified as either low-energy signals or high-energy waves. Weaker lightning stars are less consistent, more erratic, and more likely to come from an alien source. Another fascinating finding in 2022 was the appearance of another Facebook group with incredibly rapid and erratic repetitions. Since the first strange signal detections in 2001, the fast radio burst phenomenon has been steadily increasing. The only thing that is certain at this point is that FRBs, or lightning stars, are fascinating cosmic phenomena that we need to learn more about immediately. What do you think these signals mean, and where do they come from? Can you imagine that they are radio emissions from extraterrestrial civilizations, or do you think natural events are more likely sources? FREB 190-520, which is also from the dwarf galaxy 3 billion light-years away, was discovered with the FAST telescope and later confirmed by the Very Large Array Telescope in Mexico. It recorded 75 bursts in 6 months. Tell us what you think about fast radio bears in the comments section. If you have a subscription, please say it. If you like the video, we appreciate your involvement and thank you for viewing. Until next time.